Hi, good morning. I'm Mr. Gui. Nice to see you all again. Today we're going to learn about the principle of moments. Now, what's moment? Moment is the turning effect of a force. When a force at an object is able to rotate it either one direction or another direction. So that's moment. Now, what does principle of moment say? It says that when an object is in equilibrium means it is balanced. All right. The total clockwise moment must be equal to the total anti-clockwise moments about the same pivot. So that is when the object is in equilibrium. Now, if it's not in equilibrium, there is the clockwise moment is more than the anti-clockwise moment, or the other way around. The object will rotate and in certain direction, depending on which one is more. Now let's look at an example. We have a 10-meter uniform beam balanced at the center. This is the pivot. Now the weight of the beam is not important because the weight of the beam goes through the center, which is the CG of the beam, and it goes through a pivot, it has zero moment. So in this case, because it's pivoted at center, the weight of the beam is not included in the calculation because the weight has zero moment about the pivot. Now let's look at these two forces. The 10 Newton is in blue, the F is in red. Now we are supposed to calculate F so that the beam is balanced. Now the 10 Newton is exerting a clockwise moment. That means trying to turn in a clockwise direction. Now the clockwise moment is given by the formula F times D. So it's force times distance. Now, so 10 times 3 is 30 Newton meter. Newton meter is the unit for moment. Now, the anti-clockwise moment indicated by the red is also F times D, but it's rotating in the other direction. So, force times 4 meter. All right. Now, take note that we are using only this distance, which is from the force to the pivot, 3 meter. Now the 2 meter is not involved in the calculation. Also on the left hand side, take note that we are using force times distance. We are using the 4 meter in the calculation. The 1 meter is not used in the calculation at all. Now in order to balance, the clockwise moment must equal to the anti-clockwise moment. So the 30 Newton meter must be equal to F times 4. And we get that F must be 7.5 Newton. So when the clockwise moment and anti-clockwise moment balance, okay, when they are equal, the beam will be balanced. Now let's look at one more example for two forces acting on the beam. Now I've shifted the force F to here and shifted the 10 Newton to the right. Now we are supposed to calculate the force F such that the beam is balanced. So again, we must find the clockwise moment, find the anti-clockwise moment, and then they must balance. So the clockwise moment, F 10 Newton times 4. The anti-clockwise moment, F times 2. Now, so the clockwise moment and anti-clockwise moment must equal. 10 times 4 must be equal to F times 2. Then note again that is F times 2. Now this 3 meter here is not used in the calculation. Likewise, this 1 meter here is not used in the calculation. Now next, we are going on to example where we have more than two forces. We have three forces. Now we have to be careful. Now it's got nothing to do with left or right. It's either clockwise or anti-clockwise. So as indicated here, this 10 Newton and this 10 Newton are in blue because they are trying to rotate in the same direction. Now let's look at how we do the calculation to find F such that these three forces balance the beam. Now the clockwise moment is the one by this 10 Newton on the right is trying to rotate this direction. Can you see? It's trying to rotate the ruler in this direction. Now, although this is on the left hand side because it's trying to rotate it in a clockwise direction. So actually, these two forces, the 10 Newton on the right and the 10 Newton on the left, they both try to contribute a clockwise turning moment on the beam. Now, the one on the left hand side, the red F is trying to rotate anti-clockwise moment. So it's very critical to identify who is trying to rotate clockwise, who is trying to rotate anti-clockwise. Now, if we are not clear about the clockwise anti-clockwise moment, then we cannot proceed with the balancing of the equation. So now, clockwise moment, there are two components, 10 times 3 and 10 times 2. And the anti-clockwise moment we have F times D. Okay, so this F times D is 4 meter because the force to the pivot is 4 meter. Alright, so the force to the pivot is 3 meter. The force to the pivot is 2 meter. Now, if we balance the clockwise moment, the total and the total anti-clockwise moment, we find that the F must be 12.5. Okay. Now, I have example where for you to practice further. All right. Okay. Exercise 3 and also exercise 4. So if you are unable to do these two exercises, that means you are not clear with the basic. You may want to replay the video again. Thank you very much.